All right, we're going to start our unit on functions. I think most of you are acquainted with the majority of this, so I'm going to move a little bit more quickly through it. A function is a relationship that acts on all elements of the domain, which is our inputs or x values, and for every input in the domain, there's only one output in the range. The other direction doesn't matter for now. On a graph, they pass the vertical line test, as you'll see. It's a great way of thinking about seeing whether for every input there's one output. This is important if you think, for example, of a website. Like if you type a URL in, you don't want it to take you to a different website every time. It's fine, though, if you type in different URLs or different things and get to the same place. So take a look at these relationships, all presented a little bit differently. Are they functions? I'm going to try to slide this over without causing drama here. Taking a look at the first one in these sets, this is a set of ordered pairs, input, output, input, output, input, output, input, output. This is not a function because if we have 3 as an input, we get out 2 or 5, so no. Whereas this one is for every input, 3, 2, 4, 7, 6, there's a different output. It's fine that we get the output 1 twice. It just matters that for every input, there's only one output. Taking a look at this mapping or these mappings over here, this is a function for every element of the domain. It does act on it, and there's only one output. It's fine that both B and C go to Q. Okay, we can type in 2 different URLs and get to the same website. This one is not a function. While every element of the domain does get acted upon and have an output, A has 2 different outputs, not a function. This is a very nice function, that's fine. It's not a problem that we have elements of the range that aren't acted upon, but we do need that everything in the domain has an output. So this is also not a function because B is an element of the domain and it's not being acted upon. That comes up less often in actuality. This is a function. It's one you're very used to seeing, a nice little line. We'll take a look at these more. And this is not. It's actually a circle. So once you see the vertical line test in a second, you'll see why visually that is not a function. But even if you think of a table of values where x is our independent variable in this case, doesn't really matter which is which. It will still have the same. If I had, for example, x equals 0, the value y equals 3, or the value y equals -3 would cause a problem because I have 2 inputs with different, or 1 input with 2 different outputs. Here's what that might look like in the vertical line test. In the vertical line test in functions, regardless of where you draw a vertical line, it crosses at most once. It crosses the function at most 1 time. We have asymptotes, and that's not a problem for functions, but at most 1 time. Whereas in these non-functions like the circle, there are places you can draw a vertical line that goes through the relationship more than once. Okay, there are places where you could do just once, but there are where it's more than one. Domain and range, as mentioned, are very important here. Domain is the x values of the arguments, independent variables, the inputs if you think of a machine or a relationship, and the range is the y values, dependent variables. Of course, we can have different letters representing variables, but the same thing is holding true. We have discrete data, which is separate individual things, like if you're talking about the number of people, it's not split up, and continuous data where you'd use a full curve, where you can include irrational numbers and infinitesimally small pieces of whole numbers. And domain and range can be represented inequality, set builder, interval notation. We've seen all of these. You just need to be acquainted with what they might look like and feel comfortable enough using them all, but they won't ask specifically about it. Famous last words. So here's an example of a function. Find the domain and range of this function. Well, domain is any input that's possible. In order for it to be a function, you need to make sure it acts on everything, so I can restrict this domain. I know that I can't have anything in a square root using real numbers that is negative. Okay, so with complex numbers, sure, but not for now. We are going to say then, since we know that it has to be positive, or at least greater than 0, greater than or equal to 0, if I solve this, x has to be at least -1. That's a fine way to write it. You could write this interval notation where you have -1 to positive infinity, or this more complex. We have the set of x's such that x is greater than or equal to -1. All of those are fine ways of writing it. And the range is the possible outputs knowing what we have for our inputs, it's not possible to get a negative out of here. It is possible to get 0. So range is all y values that are greater than or equal to 0. Of course, similarly, we could write, you don't need to write all of these, I'm just giving you examples, or y's such that y is greater than or equal to 0. Look at domain and range. To be a little bit more clear on here as a practice, the domain and range of these, even if they are functions or not, we can still have domains and ranges. The domain is all the inputs here in the ordered pairs. That's the first one, the x. So we have the set 3 and 4. This is not in parentheses because it's not an ordered pair. Those are all of my inputs. And the range, the possible outputs are 1, 2, and 5. It doesn't say about how we map them onto each other like these do. So in this one, the domain and range, actually in both of these is the same, whereas this is a function and this is not a function. They still have the same domain and range. The possible inputs are A, B, C, and D, and the domain and the range is the set P, Q, and R. Okay. But this one is not a function because it doesn't act on all of the elements of the domain. And here, using the fact the open circle means not equal to, so that would be like explicitly just the alligator mouth without the line under it. The closed circle is inclusive. When I write the domain here and you're kind of thinking of the x values, if you were to squish this down or see where there's a possibility here, if I look at the window from x is -3 to x is 1, then I would get all of the function that's shown here. And they are obviously restricting it. It's not going on and on forever in this case. So x is explicitly greater than 3 and less than or equal to +1. Okay. And the range, for what we see here, it is ending, as said. It goes from -4, inclusive because of the circle, and actually does include -3. Not here, but there. It's of course a little bit ambiguous here, but it is going there, knowing the function. So it is inclusive of -3, just not at the endpoint. Okay, is this a function? Why or why not? No, it's not. It could be restricted in the domain, but it's saying that the domain is real numbers and that range is real numbers. But the fact that x is not defined at -1 means that there is an issue with this real number thing. So this relationship does not, it doesn't apply to all of the elements of the domain. Okay, so not all. So no. Okay, then there are piecewise functions. A piecewise function is just where you could break it up. You can do some cool things with it. Of course, relationships may change as they hit certain points. So if you're taking a look at this function here, you'll see in a second we could have y or call it something else. They're using f of x, which I'm going to show you in a second. You would just break it up into different pieces. So from -infinity to 1, I know what it is, so you don't need to worry about this for now. I just want to show you the notation. And that's true as long as x is less than or equal to 1. And then the next piece of the function, you're just saying this function is made up of a bunch of different pieces. Here's the next piece. So that's equal to 3 as long as x is between 1 and 2. And here you're just defining the domain. So not including 1, but including 2 because of the full circle. And it's saying, okay, well, that's just equal to x from x is greater than 2, or 2 is less than x. And use this to include all of those in one. If this, for example, had been a filled-in circle, it would no longer be a function because then it wouldn't pass the vertical line test. So you need to make sure it's being restricted where you don't have any overlap. Just be acquainted with the fact that that is what a piecewise function is and what it looks like. How we come up with those will come later. A little bit of notation here. F of x doesn't mean multiplying. It's just say it is a function that is defined by x. It's very helpful to write it like this. You know it's a function, first of all. You don't have to say like find y when x is this. It's already built into it. You may see this mapping notation, a little bit weird. You'll almost always see this though, but as long as you can recognize that this is implying a function and this is how the function is being defined, you'll be absolutely fine. Here are two different functions. It's nice because we can have different y's now. So here's f. I was actually going to change it. Don't even worry about this now. I was going to do something more complicated, but for time, I'll put it in the next video. Given f of x above, find f of -4. This notation, as I said, is really nice because it tells you what to do. This is saying this is x, and put it into the function to find y. So every time you see x, in these particular cases, you only see it once, but you would put it in for every other time too if you had something like this. So -12 plus 2, making sure to follow the order of operations, -10. Even if it's something a bit more complex than this, you could still put all of this in for x. So 3, this is what I put into my function. Okay, equals 8. Well, I was thinking of the last term. There we go, 3x plus 8.